So we are going to make use of this property of a cross product, that is the magnitude of cross product of two vectors is given by product of their magnitudes times the sine of angle between them. So say we have a vector A, okay, and vector B, all right, and then the angle between those two is theta. So here we have A and this is B and the angle is theta. All right, so what happens is that the magnitude of the cross product of these two would be the lengths of these vectors multiplied by sine of theta, and theta being between 0 and 180 degrees is going to be always non-negative. Now with this idea, say we are given a line, say let's call the line say L, all right, and we are also given say a point here, okay, so say we are given a point right here, all right, and we would like to determine the perpendicular distance of this point from this line. So a way we can do, or we can determine this is this, that let's take a point Q here and a point R here, anywhere is good, okay, and let me call this the vector B and call this the vector A, and if the angle is theta, then you can see that this length will be the length of the vector B times sine of theta. Okay, now you can do this. A is a non-zero vector because we took Q and R as distinct points, that we can form a unit vector there, A divided by the magnitude of A. So what you can do here then is this, that if you took, sorry, I didn't mean to say that, okay, if we did this, say we took A divided by the magnitude cross the vector B, then what will happen? Because of this property, the length of this vector will be how much? You can see that these two will cancel, right, when we take the magnitude, and all that will remain is this, and which will give us what? Which is going to give us this portion, and that's going to be the perpendicular distance. Let's apply that in a practical context. So let's see, say we have to do this, one moment, that is say we have to find perpendicular distance of this point from this line. What we mean is this, that is we are given a point and then we are given a line. So let's let this be the line, okay, and the line is given by this parametric equation, all right. So first thing, a good thing to do is this, even though it's not necessary, just to make sure that the point P does not lie on the line L. And in this case, you can easily see that, because if you set 1 minus t equals 2, then t will be negative 1. And what happens then is that for this one, t will be negative 1, y coordinate should be 1, but that's not the case, okay, and the z coordinate should be negative 2. So we have this point P here, right? Okay, let's pretend that the point P is here, 2, negative 1, 1, and let's just take, say first let's take t equals 1. So if I take t equals 1 and substitute that in this equation, what will I get? T equals 1 will make this equal to how much? 0. Okay, and then the y coordinate is 5 and the z coordinate is 0 again. So let's call this point Q, and let's now take, say, t equals, I'm just taking t equals 0. Okay, I could have done that first. So I get 1, 3 and -1. So let's call this point R. So now what we have is that we got two vectors. We can create two vectors here. Okay, let's let this be the vector B and this be the vector A. So what we had seen is that the perpendicular distance that we want, let's call it D. Oh, I'm sorry. Let's call it D. Okay. This is not a very good looking D. Let me write D again. D. Then you saw that the D is going to be what? A cross B divided by the magnitude of A, or it can even be pulled out, and that is 1 over magnitude of A times the magnitude of A cross B, right? Okay, so all we have now is that we will make these vectors and calculate the cross product. So let's just go ahead and look at this. So what my vector B is, if you look at the vector B is formed by these two, QR. So this is the initial point, this is the terminal. So we will have 2 minus 0 as 2, -1 minus 5 as -6, and 1 minus 0 as 1. And my vector A is going to be here again 1 minus 0 is 1, 3 minus 5 is -2, and then -1 minus 0 is -1. So with these two values, first what we will do is that we will calculate A cross B. So let's take that to a different screen right here and calculate it. Okay, so my vector A is, okay, A is -1, sorry, 1, -2, -1, right? Okay, so 1, -2, -1. So, and B is how much? B is 2, -6, and then 1, and B is 2, -6, 1. Okay, so if we took A cross B, okay, then what A cross B will be? A cross B is going to be, I mean, we have one way of calculating it. Let's just use that one. Okay, not this, sorry. Not this either, here. Okay, and then we will make it 3 by 3. So you have I, then J, then K, then 1, -2, -1, 2, -6, then 1. So what we have then is that we shall have this cofactor here times I, right, minus, then we got the cofactor determined by these two. So let me just do that in kind of a way I don't like to write things, but it's okay for now. So this times J, then plus determinant of this, you call it minor, this portion, so that is K. So that becomes how much? So now this will become the vector, okay, which vector? I get -6 plus 4, that is negative 2 comma, then I get 1 plus 2, so 3, and then what do I get? Again I get, just a second, I made a mistake here. Yes, I did, because I shouldn't have done this here. This was going to be this vector, right? Okay, so that's what happens when you talk to a monitor when making these videos. So this is how much? Negative 2 plus 6 is 4, and at the end what I have? Negative 6 plus 4 is negative 2. Okay, all right, so there we go. And then if we look at the magnitude of this guy here, what we have is square root of, okay, how much? 4 square is 16, plus 3 square is 9, and then plus negative 2 square is 4. So that becomes how much? A square root of 29, right? And then we will multiply it by the reciprocal of the magnitude of A, all right? Okay, or divided by the magnitude of A. And who is the magnitude of A? So this is 1 square is 4 square is 1. So that's the square root of 6, right? Okay, so that perpendicular distance that we would like here would be how much? Square root of 29 over square root of 6. If I didn't make any mistake in arithmetic or algebra or any such thing in my calculation, let me know if I did. All right, so what we got is, this is the distance here, right here, that we want, right? Okay, so this is the distance that we want. So let me know if you have any questions. Okay.